Today, we'll be learning about standard form of a quadratic equation. Standard form of a quadratic is y equals, or a lot of times I use function notation, and f of x equals ax squared plus bx plus c. Notice the a is the coefficient of the x squared, the b is the coefficient of the x, and c is our constant. Below, you have two graphs of when the graph on the left is when a is greater than 0. We notice that the parabola opens up, and if our a is less than 0, our parabola opens down. There's also a couple other points on here, including a line, that we'll learn about more as the boxes below. As we go through and look at this, our a value, if a is greater than 0, our parabola opens up, and if the absolute value of a is greater than 1, the graph of the parabola is a vertical stretch. If our a value is less than 0, our parabola opens down, and if the absolute value of a is greater than 0 but less than 1, it's a vertical shrink. That's similar to the other transformations we've learned so far. Our c value, in this case, is going to tell us our y-intercept. Our y-intercept will be the point 0, c, because it's where it hits the y-axis. And at the y-axis, all of our x values are 0. It's important when we ask about the y-intercept, you write it as a point 0, the c value. Right? If you think about it and you look at the equation above, if we plug 0 in here, our ax, it would be 0 times a, so that's 0, b times 0, so that's 0, and it would just leave us with our c. That's how we get our y-intercept. To get the vertex of our parabola, we would say x equals the opposite of b over 2a. That's going to give us the x-coordinate of our vertex. To get the y-coordinate of our vertex, we would plug in that x value, and it would be our f of negative b over 2a. That's going to be the y-coordinate of our vertex. And we're going to write that point as x, y. To find our axis of symmetry, it's the point that goes through the vertex. It's a vertical line that goes through the vertex, and it's the same thing as x equals negative b over 2a. I abbreviate axis of symmetry as AOS. Once we have this value, it's the x-coordinate, and it's also the axis of symmetry. We have a couple examples, starting with this first one. Our first one, they want us to find the vertex, axis of symmetry, y-intercept, and then graph. What I like to do with these problems is I like to go through and say, what's my a value, which is 1, my b value, which is 2, and my c value, which is negative 1. These 3 points help me because I'm going to use all those values to find other important points on our graph. When I start off with this, I also like to realize that, well, this parabola opens up because a is greater than 0. The next thing I'm going to find is the axis of symmetry. Our axis of symmetry, remember, is the opposite of b over 2a. So when we do this and we plug in our values, we would have negative 2 over 2 times 1, which is negative 2 over 2. So our axis of symmetry is negative 1. I'm going to highlight this because on my graph, I'm also going to highlight my axis of symmetry because it's going to save me time graphing some points. Once we know our x-coordinate of our vertex is negative 1, we also need the y-coordinate. So to find the y-coordinate, we would plug in negative 1 wherever we see x. I'm now going to solve this. Negative 1 squared is 1, minus 2, minus 1. So the y-coordinate of my vertex is -2. The other important point that I'm going to get here is the y-intercept. The y-intercept is 0, comma, our c value, which is -1. I have this graph to the right. If you don't have a graph paper, something like this, you can just kind of sketch the points with some critical points and label them. I'm going to go through and label my y-intercept, which is 0, -1, and my vertex, which is -1, -2. And I mentioned that I put the highlighter there before is because I'm going to highlight my axis of symmetry, because now I only need to graph find half the points to graph. If our axis of symmetry is x equals -1, we know that this point here is 1 away from the axis of symmetry, so it's also going to be 1 to the right, it's also going to be 1 to the left. We need one more point to the right or left, or we need 2 points on each side of our axis of symmetry. We already have 1, so the other one I'm going to plug in is 1, so I'm going to say g of 1 1 plus 2 minus 1, which is going to give us 2. So another point we can graph is 1, 2. If I graph that point, that's 2 to the right of the axis of symmetry. So if I move 2 to the left, we have that graph there. Now a parabola has a curve to it, so when we go and graph this, we're going to connect it with a curve at the bottom. It's not going to be a point like our absolute value. Do your best, sketch the graph, and there's our picture of our first problem. Okay. So we have 2 more examples to go through today. Our next example is k of x equals -2x squared minus 8x plus 1. Our a is -2, our b is -8, and our c is 1. We realize that this parabola opens down because a is less than 0. Right? Once we know that this opens down, we need to find some more points. The next point I like to find is my axis of symmetry. And just a reminder, it's the opposite of b over 2a. We plug in our value. Our b in this case is -8 over 2 times -2, which is 8 divided by -4. So our axis of symmetry in this case is x equals -2. Once again, I'm going to highlight that because I'm going to highlight on my graph to help save me some time going through to graph this. Now, because I already have that point, the axis of symmetry is the x-coordinate of my vertex, I also need to find the y-coordinate. Remember, to find the y-coordinate, we would plug in our x-coordinate into our equation. This would be -2 times 4, -16, sorry, not -16, -8. That's a mistake. So this is -8 plus 16 plus 1. So this would be 8 plus 1. So our y value in this case is 9. So our vertex is going to be -2, 9. Our other key point that we need here is our y-intercept. This one's an easy one, 0, c. So now with our graph, we're going to go through and plot some of these points. 0, 1 is our y-intercept, and then -2, 9 is our vertex. Like I said, I'm going to highlight my axis of symmetry to save myself some time graphing. We we know that our y-intercept is 2 points away from our axis of symmetry on the right, so it'll also be 2 points away on the left. We need one more point to the right of our axis of symmetry, so I'm going to plug in -1. -1 squared is 1. -2 times 1 is -2. -8 times -1 is +8 plus 1. So this point here will be 7. So I'm also going to graph the point -1, 7. This point's 1 to the right of the axis of symmetry, so it'll also be 1 to the left. We then draw our curve. And there's our graph for example 2. Notice I only really used 3 points. I used the vertex and 2 points to the right. I reflect them to the other side to give me 5 points to be able to graph these things. Our last example for today is down at the bottom, and it says w of x equals 1/2 x squared minus 4x minus 2. I'm going to start off by saying, well, my a value in this case is 1/2, my b value is -4, and my c value is -2. This parabola is going to open up because a is greater than 0. Right? Now, we also need to find our axis of symmetry. Just a reminder yet again, it's the opposite of b over 2a. So we'd say the opposite of -4 over 2 times 1/2. So 4 over 1. So our axis of symmetry is x equals 4. This is going to be the vertical line that goes through the vertex and makes our parabola symmetrical about that line. We also, with that value, know that our vertex's x-coordinate is 4. We need to find the y-coordinate of the vertex. So we're going to plug in 4 for our x to find the value of y at that point. 1/2, 4 squared is 16. So we would have 8 minus 16 minus 2. So we realize the y-coordinate of our vertex is -10. Okay. The other key point we can tell right away is our y-intercept. Our y-intercept is 0, -2. So when I go to plot these, I'm going to plot my y-intercept, which is 0, -2, and my vertex, which is 4, -10. And remember, we know that this vertical line, or our axis of symmetry, is going to make our parabola symmetrical. So when you look at it, this point, our y-intercept is 1, 2, 3, 4 to the left. So I'm also going to put a point 4 to the right. Now we need one more point here. So I'm going to plug in 2. You could plug in other values, but I just picked the midpoint between these because I know something nice will happen. We'll get a whole number instead of having to estimate. 1/2 times 4, because 2 squared is 4. This will be 2 minus 8 minus 2, -6 minus 2. So our y-coordinate at 2 is -8. So this is the point negative 2, 2, comma, negative 8. 1, 2. This point is 2 to the left of our axis of symmetry, so we go 2 to the right. We connect these with a curve. And we have our points in order to graph these. Notice, because our A is 1/2, this is a vertical shrink. It's going to go up half as fast as our parent function. If I also want to go back to this one, notice our A is negative 2, so it tells us the reflection. That's why it opens down. And it's also a vertical stretch because the absolute value of A is greater than 1. That's the end of the lesson for today. Your homework will be posted. Please let us know if you have any questions. Have a great day.